If you've had any interest in physics at all, you've heard about a thing called the Higgs boson. But just what is it, and why is it interesting? In 1964, a physicist by the name of Peter Higgs took some ideas that were floating around at the time, added an insight or two of his own, and proposed that there was an energy field that permeated the entire universe. This energy field is now called the Higgs field. The reason he proposed this field was that nobody understood why some subatomic particles had a great deal of mass, while others had little and some had none at all. The energy field that Higgs proposed would interact with the subatomic particles and give them their mass. The very massive particles would interact a lot with the field, while massless particles wouldn't interact at all. To better understand the idea, we can use the analogy of water and swimmers. In our analogy, the water serves the role of the Higgs field. A barracuda, being supremely streamlined, interacts only slightly with the field and can move through it very easily. The barracuda would then be similar to a low-mass particle. In contrast, my buddy Eddie, no stranger to donuts, can only move very slowly through the water. In our analogy, Eddie is a massive particle made massive by interacting a lot with the water. The lightest of the familiar subatomic particles is the electron, while in the subatomic world, the king of mass is the top quark. It weighs about as much as an entire atom of gold, about 350,000 times more than the electron. I'd like to stress that we believe the top quark is not more massive because it's bigger. It's not. In fact, we believe that both the top quark and the electron are exactly the same size. Indeed, they both have zero size. The top quark is more massive than the electron simply because it interacts more with the Higgs field. Actually, if the Higgs field didn't exist, neither of these particles would have any mass at all. Now, in the press, you don't hear about the Higgs field, but rather the Higgs boson. How are these two things related? The Higgs boson is the smallest bit of the Higgs field. To understand how that works, we should again return to water. Everyone knows what water is. If you're immersed in it, you know that water is everywhere. It's a continuous medium, and there are no holes in it. We also know that water is made of molecules, specifically H2O. If you hold these two ideas in your head with the realization that water consists of countless individual molecules, you can now begin to appreciate the Higgs boson. The Higgs field that gives subatomic particles their mass is made of countless individual Higgs bosons, just like water is made of individual molecules. You should keep in mind that the Higgs boson hasn't been discovered yet, and what I'm describing is simply the most popular idea as to why subatomic particles have the masses that they do. As I speak, my colleagues and I are studying data taken at huge particle accelerators to see if this idea is true. Stay tuned.